let's say some other parabola. Let's say if someone gives me this parabola, which is 2 times of x minus 3 whole square, and this is, let's say, y minus 5. So if someone has given me this parabola, so now just because of this 2 over here, we'll not get confused. So this is the main understanding which we have to do right now, which we have to build in our mind, that if, let's say, the equation of a parabola is given in this format, in which there is a complete square inside this bracket and there is a y minus 5, the only difference is this, that in this case there is a 2 outside. So now we know that the number which is multiplying outside this expression, it just stretches this graph. It doesn't changes the vertex. That is the important line. So if someone gives me this parabola, we can still say that the vertex of this parabola is the point 3, 5. The vertex of this parabola is the point 3, 5, just like the previous one. And the axis of symmetry would be the line x is equal to 3. This understanding, this is the only reason that we have understood that what this multiple 2 is going to do. It is just going to stretch the graph. So the location of the vertex will remain the same. The axis will remain the same. So if someone gives me the equation in this format, we directly can say that this parabola is having the vertex at this point and the axis of symmetry is this line. So just focus upon this understanding. So this is the first logic that we'll keep in our mind, that after square completion, if there is a number coming outside, but just notice, and it is very important, the coefficient of x in this completed square, just remember this line, the coefficient of x in this square completed term should be 1. If it is not 1, then make it 1. Let's say if the coefficient in this case is 3, then I'll take this 3 common out of this bracket. So 3 square would become 9 and there would be a 9 outside, but I'll take this 3 common outside because the coefficient of x has to be 1. So this is the only differentiator, if at all. And now let's say we have this parabola. So now this is the only last understanding which we have to do. And after that, we'll directly jump to questions. So let's say someone gives me the parabola y is equal to minus x square. So what happens is, in this case, let's say in the parabola y is equal to x square. If I fill the value of x as 1 here, the answer of y is 1. If I fill the value of x as 1 here, the answer comes out to be minus 1 in this one, in the second one. If I fill the value of x as 2, the answer of y is 4. If I fill x as 2 in this one, the answer of y is minus 4. So can we see that whatever value of y we are getting on the positive side, exactly same value of y we are getting on the negative side for this parabola. So this parabola is exactly the mirror image of this parabola in the x-axis. This is the parabola y is equal to x square and this is the parabola y is equal to minus x square. Exactly the replica of this parabola, but as a reflection in the x-axis. So now this is the interesting part, that this is for the first time that we have seen a downward parabola, a parabola which is facing downwards. So the interesting part about a parabola that is facing downward is this, that the term, the coefficient of x square is negative. This is the point that you have to understand. So if the coefficient of x square is negative, then the parabola that will actually ultimately achieve would be a downward parabola. So if I just extend this logic, let's say someone gives me this term, y is equal to minus of x minus 5 whole square, and let's say this is y minus 2. So using the same understanding, if someone gives me this parabola, which is y minus 2 is equal to minus of x minus 5 whole square, can we directly say that this is a parabola whose vertex is the point 5, 2, but it is facing downwards? What is the vertex of this parabola? 5, 2, but this parabola is now not facing upwards, it is facing downwards. This parabola would be facing downwards. It would be a downward parabola. It would be going up till infinity over here, this side and this side, both down till minus infinity it would be going. If I fill the value of x as 0 in this one, we would be getting the value of y is minus 25 plus 2 minus 23. So somewhere over here, it would be cutting this graph. So it would be a downward parabola. How we have judged this? Just by seeing this minus sign outside this completed square. So this is the important understanding. This is the important understanding that we have to keep in our mind from this moment onwards, that if the coefficient of x square is negative, then the parabola when drawn, it would be a downward parabola. So if someone just asks me the direction of the parabola, I just have to look at the coefficient of x square, only the sign of it. If it is negative, then it is a downward parabola. If it is positive, then it is an upward parabola. So in this case, someone, let's say, gives me this parabola, minus 2 times of x minus 3 whole square. I'm changing this as well. Let's say y minus 6. So just by looking at this equation, I can directly say that this is a parabola whose vertex is the point 3, 6 and it is facing downwards. What is the vertex of this parabola? It is the point 3, 6. But this parabola would be facing downwards. If someone asks me to find the y-intercept of this parabola, I'll simply fill the value of x as 0 here. So it would give me minus 3 square, that is 9. 9 multiplied by minus 2 gives me minus 18, plus 6 gives me minus 12. So this would be the parabola. This is the vertex and this coordinate would be minus 12, 0, minus 12. I found the y-intercept. And this is the axis of symmetry for this parabola. But the sense is very important, that the coefficient of x square, if it is negative, then the answer of that parabola would be a downward parabola. So this sense is to be understood, it is very important. So let's now attempt one more question in which simply you have to find the vertex. First you have to do the square completion, but in the square completion part also, you just have to understand that even if it is negative, let's say someone gives me this parabola. Okay, let's solve one question and then we'll discuss further. So just attempt this next question now. So this was the term. We were given the parabola y minus 6 is equal to minus 5 times of x minus 1 whole square, and we weren't even told to complete the square in this question. So if I have to mention the vertex of this parabola, so that was simple. It was the point 1, 6. We can directly judge this. So in this case, the axis of symmetry would be the line x is equal to 1. And the important part was this, that can we directly say that this parabola would be a downward parabola? This parabola would be a downward parabola with the vertex at the point 1, 6, and this parabola would be facing downwards. And what would be the y-intercept? For the y-intercept, I simply have to fill the value of x as 0. So 0 minus 1 becomes minus 1. Square of minus 1 is 1. So the answer of y minus 6 is equal to minus 5 multiplied by 1, which is minus 5. So y comes out to be 6 minus 5, that is 1. So this would be the exact shape of this parabola. This coordinate is the point 1, 6 and is cutting at y is equal to 1. This would be this parabola that has been asked. And this would be a downward parabola. So the only requirement in this case for you was to just complete these terms. And in this case, this would be the axis of symmetry, which is the line x is equal to 1. So before going any further, before going into this topic more deep into this topic, because after that in the next class we are going to build concepts based upon exactly these logics, and after that all these questions will just fall into line. But the first important task is this, that you are able to answer these basic questions. So whatever we have done in today's class, that is the most basic part. So now this is the part upon which the entire chapter is based. So just recall everything that we have done today, and in the next class we are going to move further based upon the logic which we have done in today's class. So take care, all the best, bye.